Hey everyone. Today we kick off our sort of mini unit on factoring. Factoring is a pretty major topic in algebra, and I want to start out just by talking about the goal of factoring so you can have sort of a big picture in mind with what we're attempting to do. Factoring means to break something into its factors, and factors are things that multiply together to make a larger number. So, for example, if I gave you the number 15 and I asked you to factor it, you could write it as 3 times 5, and that's a factored version of 15. Okay? So factoring is all about writing things as a multiplication problem. We want to write things as a product. And there's a whole bunch of reasons in algebra that you would need to do something like that. You've seen some of that already when we did some of the polynomial stuff, but that is our goal. Our goal is to write something as a multiplication problem. Now, this type of multiplication problem is really simple, right? But we've seen lots of different types of multiplication in algebra, and we're going to be looking to recreate all of them. So, for example, I've given you multiplication problems that looks like this before. Okay, that's multiplication. It's distributive property, but it's multiplying. Where you're going to go like this, 3 times x and 3 times 2, and you're going to call it 3x plus 6. The goal of factoring is to take something that looks like this and turn it back into this thing, because this is a multiplication problem. Okay, so we're like undoing the distributive property. We've also done multiplication with FOIL. We've done multiplication where I take things like this, x plus 4 times, I don't know, x minus 6, let's say, and we've turned it into x squared minus 2x minus 24. Okay, we've multiplied things together that way. What we are going to be doing when we're factoring is taking something that looks like this and turning it back into these. That's going to be in a separate video that we talk about that. But so again, end goal is to break these things into as many tiny pieces as we can that are all multiplied together, because that allows some other math to take place. That allows us, first of all, it allows us to identify some things about these functions that you're going to learn about in the second half of this chapter. It also allows us to do some manipulation and canceling things out and stuff like that. So factoring is going to be one of those skills that you want to get to the point where you can do it very fluently within the context of another math problem. Okay, so we're going to cover this first section here, factoring with GCF. And the GCF factoring is really this. It's where we're taking something that is all simplified and pretty, and we're turning it back into something that looks like a distributive property by pulling this thing out in front of a set of parentheses. And this thing is the greatest common factor of whatever terms you started with. So if you look at 3x and 6 and you ask yourself what divides evenly into both of those, a 3 would divide evenly into both of those. Okay, and so that's why I was able to put a 3 out front, and then if I take the 3 off the 3x, I'd be left with an x. If I take the 3 off the 6, I'd be left with a 2. And then if I multiply this back together, I could get my 3x plus 6 back. So when I look at this first one, I'm looking at 3x to the fourth and 9x squared and asking myself, what do they have in common in terms of factors? What multiplies into them evenly? Okay, so let's start with just 3 and 9. Well, 3 and 9 have a 3 in common. Okay, and then if I have x to the fourth and x squared, how many do they have in common? Well, you can't have more in common than the smallest number of x's that one of your terms has. So the most you could have in common is 2 x's. So I'm going to say 3x squared is my GCF. Okay, so this thing here is the GCF of those two terms. Okay, and that's the idea, is that I'm pulling that out in front. Now I'm going to open a set of parentheses, and I'm going to figure out what would have to go right here to make it to where if I multiply these two things back together, I would get my 3x to the fourth back. So that's the question I'm really asking when I say what's left over, or what's left when I take a 3x squared out of 3x to the fourth. Well, 3 times 1 makes 3, so really this is like a 1 here. You wouldn't technically have to write that 1 there, but good habit to get into. And then if I have x, if I'm pulling out an x squared and this was an x to the fourth, there would be 2x's left here. So just think to yourself, 3x squared times 1x squared, that would give you 3x to the fourth back. Now I'm going to think about the 9x squared. So if I take the 3 out of the 9, I would be left with, in terms of division or in terms of looking for a factor, I would be left with a negative 3. Because now if I multiply this back together, 3 times negative 3 gives me that negative 9. And I'm taking the x squared off, meaning there's no more x squared here. So this is just going to be a negative 3. Okay, so just so you can clearly see what my final answer would be here, it would look like this. 3x squared times x squared minus 3. That's my factored answer. That's what my goal is. Okay. Okay, let's try the next one. The next couple will go faster for sure. So I'm looking for, what do these three things have in common? 15, 25, and 5. Well, they all have a 5 that divides evenly into them. Now let's look at my m's. I have m to the 8th, m to the 4th, and m squared. So if I needed the same amount from all of them, if I needed to take out the most that they had in common, it would be this one. It would be the m squared. And then my n's, I have n to the 5th, n to the 6th, n to the 3rd. So the largest number I could take would be that n to the 3rd. Okay, so that's my GCF. That's my thing that I'm putting out in front. Now I'm going to open a set of parentheses and figure out what's left. So if I take a 5 out of the 15, so 15 divided by 5 is 3. I'm taking 2 m's off, so that's going to leave me with m to the 6th. Excuse me. And I'm taking 3 n's off and had 5 originally, so that would leave me with n squared. If you wanted to double check right now, multiply these two things together, 5m squared n cubed times 3m to the 6n squared, and make sure that it would give you back this thing. Okay? Minus, now I'm taking 5 off the 25, so that would be a 5. I'm taking 2 m's off, and I had 4 to begin with, so that would be m squared. And I'm taking 3 n's off. I had 6 to begin with, so that's n cubed. When I say I'm taking them off, by the way, really what I mean is that I'm dividing by those. And remember that when you divide with exponents, you subtract. So that's why you see me subtracting or taking away that number of m's or n's. Okay, this last little bit is tricky because when I look here, I see if I take a 5 out of a 5, I'm really left with a 1, and I know that we kind of get in the habit. I mean, even up here, I said we don't really need this 1 here. But look at what else is going to happen. My m squareds are going to go away completely, and my n cubes are going to go away completely. Like this whole term got taken out. And so what I see people do sometimes is they go, oh, hey, this whole thing's going to cancel out. I can just close my parenthesis here. There's nothing left. But remember, the goal is to be able to multiply this back together and have it turn back into the original. And if I don't put something there, I'll never get this term back. So when you don't have anything else there, you do need to make sure to put a 1 in that place. The 1 didn't matter here because there was an x squared there that was going to kind of have a 1 in front of it, whether I wrote it or not. But if there's nothing else there, you have to make sure that you put a 1 there as sort of a placeholder. Okay, so now let's look at this third one. This third one's kind of a special case here. It looks a little confusing, and some people might start distributing here, and I guess you could do that and maybe find a GCF, although I think it's going to be hard to do. This is going to lead to something called factoring by grouping, and so this is a very unique type of problem, but we're going to see this show up later. Here's what I want you to wrap your head around. This thing here is all one term, and this thing here is all one term. So I've got 2 terms here, and the question I'm asking myself is, what do the 2 terms have in common? Well, what they have in common is this parenthesis. They both have a 6a plus 2b. So that is what I'm going to pull out as my GCF. So I'm going to take this 6a plus 2b and pull it out in front again serving as my greatest common factor. This is what the two terms have in common, is this thing. So if I take that off of this 5a squared term, if this is gone, all I have left is a 5a squared. And then over here, if I take that off of this term, I'd be left with a 9. Okay? Now, if I were to ask you to multiply these two things back together, you probably wouldn't write it this way. You would probably FOIL it and have like 4 separate terms. But technically, that's what you're doing, right? You could think of this as like, I'm taking this whole thing and distributing it to the 5a squared, and then this whole thing and distributing it to the negative 9. That's what this statement is saying. So this would be your final answer here. Okay, that's it for factoring by GCF. We're going to pick up in the next video with factoring trinomials.